Hello, it's the second one of these live streams, and let's see how this goes. So, in case you didn't catch yesterday's one, it should still be around on YouTube. It's probably not around on Twitch because I didn't realize I had to tweak some settings to keep old videos around for a few days. So that's sorted out now, and hopefully today's one will start leaving a trail on Twitch, at least for a little while, but they'll be on YouTube permanently. And I'll figure out a playlist and all of those things. So what are we going to do today? In case you've sort of not gathered, I'm Simon. You can find all of my stuff at my website down there, simonprickett.dev. And you can follow me on Twitter, Simon_Prickett, which is slightly annoying. I have the underscore there, but not everywhere else. So for example, if you went to my GitHub, that doesn't have the underscore. I don't know why I did that, but it was a long time ago, maybe before I sort of understood that having a consistent handle across everywhere might be a good idea. So I'm Simon. I am just generally using this space for some sort of casual live streaming about pretty much anything that's going on or whatever I'm doing. I'm usually working on something with some sort of Raspberry Pi or Arduino or increasingly Raspberry Pi Pico projects. And I do other stuff. I might do some software things. If you check out on my website, I occasionally build some Lego. We've got some pretty large Lego sets down there. I'm not sure building the Lego Concorde would necessarily be the most interesting live stream, but you never know. Like a 10-hour silent video building Lego might work for some people. So I'm going to try and make these more days than not, or at least Monday to Friday. I'm currently in between jobs, so you can also hire me if you are interested. Details are on the website, or just catch up with me if you want to chat about that. That's not really what this is for. What we said we would do today on the stream is I've got a hold of this thing, which is the PiHut Maker Advent Calendar. There's actually two versions of this. There's one that's more LED based, and this one is more inputs and outputs, and I don't know. I've literally not looked into it. I bought this thing pretty much blind on recommendations. As I said yesterday, as far as I've got with it is open the box and discovered that there's sort of beautiful presentation here of like 12 different things. So what we're going to do today is open box number one pretty much blind and figure out what is in there and what we can do with it. So if you wanted to get one of these, they are still for sale. So we'll come to having a look at that in a moment. But I also just wanted to cover like, what have I done? I'm going to try and make this a little bit of a vlog. So what have I done since yesterday's stream? A couple of things. Some stuff's arrived in the mail, so we'll check out what that is. I had a job interview, which is, I think, the third for this particular position. We'll see how that goes, if there's any feedback from that in the coming days. What I've found is applying for like senior developer relations, developer education lead type positions. People love interviews. So it's like, you're going to get 7 or 8 interviews. And what I've also found is you get ghosted a lot, which, is disappointing from some relatively big names, but it's what it is. So that's one thing that I did yesterday. One thing I'm actually really enjoying about interviewing is just chatting to other people who do this stuff, regardless of the outcome. So it's working out well for making contacts. So early in the morning, well, not early in the morning, it's like 11:30. But I've just got the first AeroPress of the day on. So I think another recurring theme on this stream will be I enjoy making coffee. I've got an AeroPress. I've got 2 AeroPresses. And I'm doing something coffee related later this week that hopefully I can talk about on here towards the end of the week, maybe. So what came in the post today? We have a couple of things, and we're going to kind of up the tech game here a little bit, and let's see if we can add. Here we go. Add the second camera. So we have a couple of things came in the mail. So first off, we have this box, which contains a Pimoroni Badger 2040W, which is one of these things. So it's the thing that I'm using to build my ISS tracker. It's an e-ink display. It's got buttons on it. In the back, it's got the Pico W kind of pre-soldered onto there, so you don't have to do anything with it. And then I put these legs on there. They're actually the legs from a different Primaroni product, and they fit really nicely because then it will sit like that. I am making a couple of relatives one of these trackers each for Christmas, so I needed some more hardware for that. And normally I would just buy the Badger, which is like the screen unit. And what I've got this time is, and I just realized I can do this. There we go. That's better, isn't it? What I've got this time is I went and got the accessory kit. So it came in this extra box. And if we open this up, what we'll see is this here in the shiny static bag. That's going to be the Badger. So we know what that looks like. We don't need to worry about that. This comes with a lanyard. It is a badge. It's got this like thing here, like it could be hung on a rack in a shop, or you can clip the lanyard to it and wear it. And part of making it useful like that is obviously it needs to be powered by something if you're going to do any sensible logic. So this is the ink. You can leave it turned off and nothing's going to change on that display. But if you want it to update periodically, you need power. So if you imagine I've got it around my neck on the lanyard that is in the kit, it also comes with a little battery box. That feels quite heavy. Yeah, the batteries are already in it. So it's 2 AAAs. Didn't have one of these before. And it comes with another USB-A to micro USB cable. Probably the most useful cables when you're working with IoT stuff is one of these that does data. Although increasingly things are moving to USB-C for connecting your microcontroller or what have you to your computer. So that's what we got. Oh no, there's something else. There's also a bit of sticky Velcro. And if I remember correctly, what this is for is you attach it to like the back of the badge here, and then you attach the battery box to the Velcro. And then the badge has got a battery input there. So then you've got something that's powered entirely off of batteries. The ISS tracker isn't the best project for this because it's quite network heavy. It makes a lot of network calls, so the Pico is active and it's on the Wi-Fi quite a bit. But let's sort these cameras out too. We can do that. So whilst I've got these things, I'm not going to use them on the ISS tracker project. I'm going to use the accessories for something else. But I thought I'd just get an accessory kit because the postage was the same anyway. And now we have this cool box. One of the things with getting IoT stuff is you end up with a massive stack of, let's put it back, of nice boxes. And I've also got a huge pile of stuff that I want to sell on eBay that, these boxes would be great for. But obviously the fun bit with doing the IoT projects is buying things and doing new stuff and not necessarily the grind of listing the stuff that you're finished with on eBay and selling it. But we'll get there. So yeah, we got a Badger kit. There's the bag and all of the other bits and pieces. And then we got a second thing. Luckily, Royal Mail came just before this stream because otherwise the doorbell will be bugging me while I'm on stream. And the second thing we got, let's swap the cameras back around again, is I'm not even taking this out of the box yet. It's in quite a cutesy little square box. And what it is it's a specific sort of smart plug. So I haven't looked at this. So here we go. There's the UK plug. There's a UK plug, and then a power socket or a power switch. And it's what's called a Tasmotor plug. So it's got, this is apparently the entirety of the user manual. But what I wanted from this is a smart plug that can be turned on or off by a device without connecting to the internet. So this thing can be on our network, and it will have an IP address or whatever, or it might do Bonjour, or it might have a name. I don't know. We'll figure that out on a future stream. And the idea was I wanted to be able to control it easily with an API and turn it on or off, so that this thing here, it's upside down, look at that. This thing here, which runs my electricity carbon intensity monitor, can then turn something on or off. So when the carbon intensity is bad, there's our electricity is being created by essentially burning a lot of natural gas, then we can turn off for whatever it is, the thing that's charging the battery pack or whatever we choose to connect this plug to. And when things are greener, then we can turn it back on again and get some charge, so that we only charge in the good times. I've just plugged this in. Let's see if that's super bright. Let's let it settle down and see what our current electricity looks like. And as I expected, because it nearly always is here in the East Midlands, it's bad. So my electric at the minute is essentially natural gas. That's where the majority of things, or the majority of the generation is made up from. So never mind. Not a good day for charging things. So that's what came in the post. And let's put this plug back in its little box here. This bit of paper is literally all you get with it. So hopefully it's got a URL or something. Or we can ask the good people of Twitter if they know anything about these. Tasmodes seems to be quite a common thing. I've no experience with it. So that was the mail bag. The other thing I wanted to do was just move some things around here quickly. The other thing that I did yesterday, so job interview, and I also let's switch to a view that uses it. Maybe. Ooh, there we go. Don't need a second camera. I also did a bit of work on my website. So my website has like a load of projects that I have done over the past, I don't know, maybe 6 or 7 years of working on this stuff. And what you'll see here is typical project page. I built a task tracker with an Arduino and LED arcade buttons. And it's like Simone Yetch's. If you've seen her, she's got an annual task tracker thing. What's exciting about that is you can now buy it internationally as well. It used to be for US shipping only, but hers you can now buy internationally. They are quite expensive though. They're about £260. But if someone wants to buy me one, I'm not going to say no. So I did a thing that was a little bit cheaper for like 1 week. So it had some buttons. And there it is. And the idea was you pressed all of the green buttons and they stayed lit up. And that was your sort of, I've done the task from Monday through Saturday. And then the red one was a reset. And I use these Adafruit arcade buttons that are great. And I'm terrible at building things. And I don't have a 3D printer. So I used an electrical junction box. And my idea of doing front end was, I'm sure there's some pictures of it in here somewhere. Here we go. Taking power tools to the box and just drilling appropriate size holes in it and then screwing the arcade buttons in and a big old mess of wiring. And you can see there that's my dog. Back when I had a dog, he was not impressed by this and he just fell asleep. Anyway, why are we talking about this? So all of this stuff on my website, I kind of do. There's no ads on the website. There's not going to be any ads on the website. But as of yesterday, there's this little orange bubble. So that's the last I'm going to say about it. If you're interested in supporting these projects, I've got a Ko-Fi, which is kind of like a buy me a coffee thing. I may or may not buy literal coffee with any donations, but the aim is it kind of goes to fund future madness and toys and stuff for doing projects with, which end up on the website. So there's one of these little banners somewhere on every single article on my website now. That's something I did. How did I actually do that? It's this website's built as a GitHub Pages website, so it uses Jekyll. It doesn't have to, but it uses the Jekyll static site generator because that's kind of like the easy path with GitHub. And then I have Cloudflare in front of that because I wanted to do some logic and run some JavaScript on some URLs so I can build some semblance of a mini backend for some things. I have a bus API that runs on here, and that runs entirely on Cloudflare. And then this is just a theme that I got from, I think it's down the bottom. Yep, from these guys, Mundana. That's just a theme that's designed to look a little bit like Medium. So if you go here, this is the home page, and like I can put tags on the article and say this is the sticky one that sticks around here, and then I can have a featured tag and things stick around in this list. And as new things come out, they get pushed down the page, and then they eventually sort of paginate off that. So I've been pretty pleased with this setup. I have considered moving it to Cloudflare Pages. Now that's kind of a free product, but this isn't really causing me any trouble. So the fact it's Jekyll's based on Ruby. I'm not a Ruby fan, but I've mitigated that. I just run the thing in Docker locally, so I don't have to deal with Ruby's seemingly quite arbitrary dependency mechanism. So yeah, that's the website. So what I did yesterday was created an include file, and now every article at some point I just drop that include in there, and it just drops a little div in there and it's like, hey, go buy me a coffee, and let's click through and show this. So if you wanted to buy me a coffee, they're set to £3, and that's kind of cool. And we'll see if anyone does. But that's not really the main point of it. That's just a thing to help us out. So back to what I said I was going to do today. We've got this thing, the Maker Advent Calendar. So let's actually get on with looking at what it does. Here's the other one down here. So there's this one that is Let It Glow. It's LED projects. I chose this one of the two because I figured it might have a bit more variation of things, because the other one seems to be focused on LEDs. But we'll see. And all I know about this whole thing, other than it looks like this, which is great. I love the attention that they put into this. All I know about it is what's written here. So we've got a Raspberry Pi Pico H. So what does that mean? It's a little microcontroller. It's got the headers pre-soldered onto it, so we can push it into a breadboard or plug things into it without doing soldering. So I guess they've done that to make this quite an approachable kit. It's just an H, so I assume it's not a WH. A W1 would have Wi-Fi, so we're not going to have Wi-Fi networking on here. We're not going to have any networking on here, except maybe... No, I don't think the H has got Bluetooth. I think that comes with the Wi-Fi one. And it says we get a micro USB cable and a breadboard. So I guess what we're going to do is connect it to the computer and the breadboard and do some stuff. Let's click view more. So each day we'll learn how to make a new Pico project with the box's components via daily online box guides. So, okay, let's see what we've got here. So this is new to me. I'm literally doing this blind. So we'll see how we get on. So we've arrived at this page, and we do have one of the Advent calendars. So lucky us. I bought this one for myself, but if you're receiving this as a present, it looks like a really good thing to receive. So select the image of the Advent calendar you have got. So we've got the more sort of red box. And okay, so now we've got guides to what to do. So the aim today is to do whatever day one is. And the aim by Christmas, without this necessarily being a daily thing, because I do have other things to do some days, is to get down to all 12. So we're going to start with day one today. Let's click this and see what happens. Okay. I also like that these are online, so you could check all of this out before you spend £40 on this kit if you were not sure, or if you were buying it for a child or someone you're not sure what level they're at. But anyway, we are here. So, okay, we're going to learn about MicroPython using a Raspberry Pi Pico. So this is something I know a bit about already. And we're going to use code to make hardware interact with the real world, which is kind of right up my street. So we're going to find out what's in the box. And here we go, day one, getting started. So we'd better open box one. Do that. And let's bring back our friend with camera 2. And maybe let's do this for a minute. Make camera 2 nice and big. So let's see if I can fat finger getting box 1 out of here. That's it's box 1. So I like that they're color coded as well as numbered. Let's take this apart. So the spoiler was we can expect to find that's a USB cable and a breadboard. So if you don't know what a breadboard is, it's basically a way of building circuits without doing soldering. You can push wires into these, and they have connections between the tracks on there, and we can build circuits. Looks like this one's got a pad on the back, so we could stick it to something as well. And that's a micro USB cable, USB-A to micro USB. So that's the second one of those we've received today, because we got one from Pomeranian in the budget kit. So open that. Yeah. Okay, breadboard and cable. I'm going to discard the bag over there for a minute. I'm not actually going to use this cable because I have one already plugged in here, because I'm working with PiCos and stuff most days. So I don't have to go crawling around the back of the iMac that runs this stream to put this cable in. So that can go into our stockpile of stuff, and then so in this little, like, it's about the size of, I don't know, an eraser or a small thing of chewing gum or something, is a Raspberry Pi Pico H. So this should be something that I throw on the floor. These things are very slippery. Also, this is where you discover that Simon is left-handed, and his left hand is a bit damaged from an accident I had a while back. But never mind. We'll get there. Right, let's discard the box. And out comes our Pico H in this cutesy little box. So here it is. Try and get it into focus a bit. So it's got the USB connector for micro USB. It's got these headers pre-soldered on. If you're going to do projects with these microcontrollers and you just want to get on with it, I would strongly recommend always paying the extra, not very much, to get the one with the headers, because the one with the headers is going to save you like having to do about 40 of these solders, and they all have to be correct. And while it's fun to do that a couple of times, it gets a bit dull when you have to do it loads of times. So we've also got hi Mark. So if you don't know, Mark works for Balena.io, which is a company that manages basically containerizing things on the Raspberry Pi and managing fleets of them. One day we need to do something with that still. You will see that behind me there, pointing at things is hard. There's a load of Raspberry Pi 4s that are kind of ready for that, and they're all identified by different colors and they've got their own heatsink things. But that's not today's project. So let's keep going with the Pico H here. So we've got the Pico H, we've got the cable to connect it to the computer that we're not going to use. I've already got one of those, and we've got the breadboard, and that's it for today's box. So let's see what we're going to be doing with today's stuff. I don't like that view. That's better. And we don't need second camera. Right. Like day one getting started, you'll have already noticed that the first box is larger than most of the others. This is true. It seems like the first box was big and the last box is big. So maybe the last day is something extra cool or something, I don't know. And the other boxes are all like a uniform smaller size. So we've got all of these things. Building Lego and stuff teaches me that the first thing you should do is like null your objects. If you see like Adam Savage, lay them out and make sure you've got everything. So breadboard, Pico, we've disregarded the cable because I've already got one plugged in. So today's project, we're going to get you set up and familiar with the Raspberry Pi Pico, including installing the software required to program the board, as well as running a couple of easy projects to get to grips with MicroPython. So we're going to use MicroPython, which is basically Little Python for microcontrollers. These things don't have operating systems. So basically, the only thing that runs on there is your code, and you have to do everything. So if you're familiar with writing Python on a normal computer, that's a little bit different. So if you've got a Pico here and you want a Wi-Fi connection on a Wi-Fi one, you have to write code that opens that up and manages it. So MicroPython is not normally, the runtime is not normally installed on these out of the box. So I'm guessing we're going to have to do that. So what else does this tell us? The board has lots of pins around it called GPIOs. It does. That's what these things that stick out are. Think of those as like on-off switches for real-world things. We can send some voltage to them or not, but also we can use them as inputs. And I guess we're going to explore that over the coming days. So yeah, there's a picture of what we've got. That's definitely what we've got. So to do some programming with this, you can use various different tools. It looks like they've gone with something called Thonny, which is a pretty basic IDE programming environment that's set up for this sort of thing. So here's Thonny, it's thonny.org. I actually had this installed already. This is it running. It kind of looks like a basic IDE. This is a shell down here. It's not connected to anything at the minute. This will be where our code appears. This is just the file system on my computer. So we've got that already. Don't need to worry about that. But it looks like there's some decent instructions here for how to install Thonny, including if you're on Windows, which is nice because a lot of people don't provide instructions for Windows. And here we go. So we probably need to do this. Install MicroPython on the Pico. So a handful of customers are experiencing an issue. Okay, well, we'll try this method and see what happens. So I plugged the Pico into the breadboard. So let's bring back the big camera. So plug the Pico into the breadboard, and it says they want it so that the USB is like sticking out of the end like that. And it looks like we need the headers in the C and the H track. So these tracks, focus isn't necessarily great, but these tracks have got letters on. So we want C to H like that. And I'm going to give it a good. You do have to be fairly firm with these things. A good shove, and it's now located in there. You also need to be a little bit careful if you take these out, because if you don't do it with a sort of even levering motion, you'll rip it out and bend all of the pins, which is not a disaster. You can put them straight again with pliers, but you don't want to do that too many times. So there we go. And also, Mark says, let's make it happen with regards to a Blender project. Yeah, definitely. I literally got all the hardware. I've set it up in Blender, and we'll come to figuring that out. So we've got the thing connected to the breadboard. So yay that. Now it says locate the little button on top of your Pico. This is the boot cell button. So that's this thing here. That's a button we can press. It makes quite a satisfying noise. And what that allows us to do is basically install firmware and things on the Pico. So what we're going to do is, this is a fairly common thing with these Picos, is we're going to hold down that boot cell button whilst plugging the cable in there, and the cable's connected to the computer. So let us go back to here, and I'll leave the second camera knocking around for a while. Part of testing this is seeing what works with the streaming software. So in the summer, I did this before and had the second camera connected like it is now. So the second camera is connected to the same computer that I'm using, and it's just a second view. It's got a USB cable. And in the summer, what I found was things got really, really hot and the computer started having thermal issues. So I ended up moving the second camera to another computer that's next to me and then inviting it to the stream as a guest. So I moved some of the load off of this fairly capable iMac, which was still having heat issues in the summer. But now we're in the winter, it seems to be a lot better. So I'm mostly testing the system out to see what works with this stuff. At some point, I need to get my Stream Deck back so that I can just press buttons to move between views rather than sort of go look over there on the spare monitor and change things. Anyways, back to what we're doing. So we got to install MicroPython. So we're going to hold down the boot cell button and attach the power. So I'll do that now. Okay, so what we might see is we might see it pop up as a new device on our computer. Did we see that? Not necessarily. So let's see what's going on here. Okay, so what we need to do is in Thonny see if we can connect to this. I've never actually installed MicroPython this way before. I normally do it a different way. So let's see. Install MicroPython. So yes, Thonny, you can access devices on a removable volume. So it's found this. This is what it shows up as. So RPi RP2 is what a Pico shows up as. MicroPython. We've got to choose what sort of Pico we've got. So we've got a Pico H here. And let's have version 121, which is the latest. And let's hit install. I've literally never done it this way before. The other way you can do this is you can download what's called a UF2 file, which is an image file. And you apply power to the Pico with the boot cell selected, and it pops up as a second drive on the Mac, and you drag the image to that, and then it reboots, and you've got MicroPython. But let's try this and see what happens. So copying, off it goes, waiting for the port, done. Okay. Let's see what happens now. Let's see if we can connect this. Hey, there we go. So we've connected Thonny to the board being now attached to the computer. It's tethered by this cable. And we've got a MicroPython REPL here. So if you think of this as sort of the operating system for this machine, that's a good way of imagining it, except everything's in Python. So if you had like an old boot to basic computer, like a ZX Spectrum or a Commodore 64 or BBC microcomputer or any of those, then it's a bit like that. So we can't do DOS type commands or Unix type commands, but we can do Python stuff. So we could basically do something like print 3 or 4 plus 3, and it's going to do that on the device. What's cool about MicroPython is it has additional libraries to deal with those header pins, so we can talk to real world things. But in terms of what we're doing, we're basically just running Python on here, and there's nothing else going on this machine. So let's see what we're supposed to be doing. That's kind of a bit of a digression. So at the time of writing, it was 119.1. This might be a little bit old. It's now 121 something, but that's fine. So we've got Thonny connected to this because I kind of was using it for other Pico projects before. We've got that, and this is something else I set up yesterday. I'm going to keep digressing. You know, I said I set up the Ko-Fi thing for buying coffee and stuff. I also configured the stream bot to do this like 30 minutes into a stream. And yesterday's stream, I kind of realized I didn't talk long enough to trigger it. So I couldn't test it, but there we go, it's working. So I'm happy with that. Right. So yes, we're ready to code. Yeah, we've got a REPL. So we need to make a very simple program and run it on the Pico. So we'll tell the Pico to print some words known as a string. Okay, so pretty much what I just did in the REPL there. So what we need to do is create a new file. We've got an untitled file, so it's just an editor. And let's use the handy copy button here and paste that in there. So print, this is my Pico talking. And then what do we need to do? Select the green run icon. So here we've got an unsaved file, and what we can do is run this sequence of commands on the Pico. And what you'll see has happened here is when I press that button, it rebooted the Pico, so it restarted the MicroPython environment, so we've got a clean one, and then you get the print output that I expected to have. So we're all good there. Yes, we've got a first program. So yeah, as with regular Python or big Python, as I think Matt Trentini over in Australia calls it, I kind of like that. It's like, you know, big Python is big and MicroPython is cool. But they're largely the same. The syntax is the same. So we can change anything and we can do what we want. And I don't like pineapple on pizza. That's heresy. My favorite pizza is pepperoni with pineapple, which actually came about because I used to live in California in the 90s when you used to have to phone Domino's for your order. And they screwed up my order at one point and put pineapple on my pepperoni pizza. And then I was like, this is genius. And it's been my pizza order for decades. Anyway, so we can do Python stuff, and then every time we run it, it's going to do that. So I don't think we need to actually do that. So activity 2, turn on a light. So these boards have an onboard LED. It's not like a fancy multicolored one or anything, but we can turn it on and off, and that's usually the sort of IoT hello world, right? It's like blinker. So the Pico comes with a little LED on board, and let's also be a good citizen and remember to make this a bit bigger. There we go. And the LED is attached to one of the pins, GPIO 25. So what that means is all of these pins around the edge of the board here that you see, there are the silver things that are now like buried in the breadboard. They've got numbers associated with them. So 25 is not one of those. It's already wired up to that little LED on the board that you can see there. And oh, hello, it's Abner from LOC, which is Ladies of Code London. They run like co-working events on Sunday on Zoom, and they're a really good place to go and get stuff done. So hello. Right. So yeah. So as this says, we can use the GPIOs as inputs or outputs. So inputs are when we want to send some current into the Pico and do something with it. So imagine like you're building a web front end, like you press a button, an event happens. In this model, you press an actual physical button and like electricity happens and your code can respond to it. And outputs are for controlling things that go things. So we've got an LED that's an output. So a bit like Python, we need to import things if we're going to use libraries. So let's see. One of the things that MicroPython comes with is an abstraction for these GPIOs. So it's got a pin library, or rather it's got a machine library, which has got a pin class, or I don't know what it is, class type thing. And what we're going to do is use that to tell MicroPython what we want to use GPIO 25 for. So it's always going to be an output in this board because it's got that LED physically connected to it. And then what we do is we toggle it using value 1 or 0. So let's, well, I had to select that. Let's copy that and paste that. And let's try, and somewhere here, we can do something like this. Oh, that's probably better. So you can see the code over there. And you can see here that nothing's going on with this Pico at the minute. If I click the magic green button across my hands here, shouldn't do that. That's going to be a mess. Hey, you can see that LED came on there. So we've got a little bit of MicroPython running that is turning the LED on, and then it's going to stay on until we either cut the power or change that to 0, run the code, we've got 0. As we get a bit more code, look, make this a bit bigger. This is actually a 5K iMac, so I kind of forget that the very high resolution screen doesn't necessarily always come across on streaming, which is regular HDMI or regular 1080p. So if things are too small, please remind me. I will try and preemptively do that. So we can change this value from 0 to 1. We've set pin 25 to be an output, and this is just library code that is a MicroPython thing for dealing with these. So if you notice, this is kind of portable, right? So if we had a different board that wasn't a Pico, we had like an ESP board or something, we just get a different MicroPython runtime that is built for that. And then the code looks about the same. The pin numbers might be different depending on how we've got things set up, but we'd still be doing from machine import pin. There's nothing here that is like super Pico code specific. So we've done that. Try changing the 1 to a 0. Yeah, we did that as well. And you could also try adding a print line at the bottom to show a message at the same time. And then that's it. So day 1 complete. But let's just do something a little bit more interactive, because so we could do something like this. So one of the things with these devices is when your code and nothing else is running on there, if your code stops running, nothing else is there. So if you want code that runs all the time and reacts to events, it kind of needs to be doing something all the time, or sleeping, waiting for things. So what we're going to do is, let's do, I don't know, we can do that. So regular Python stuff should apply. So we can do sleep 1. So this is going to be a loop that sleeps every second. It's going to turn the LED on, and then let's change that to be value 1. And then there's probably some better ways we could do this, but let's do just something basic. Equals no else equals 1. So yeah, it's going to basically toggle the LED, hopefully. So let's see. That's not great Python code, is it? What am I doing here? So, don't assign it. There we go. So we've now got, you can see it there, an LED that's toggling every second. So we've got some code that has basically every second toggled the value of a variable, and then we're passing that into that LED pin, and it's turning current on and off, and we get a flashing light. So that's kind of it for day 1 of the Advent calendar. So I don't know, what do we think of that? I think that was pretty good. This is aimed at people who've maybe got no electronics experience, or maybe some Python experience, or what have you. And I feel like this is let's change that. I feel like this is a pretty well pitched thing. And it seems to be really well done, because quite often doing something simple and getting people to the start line is the hard part. So we have successfully completed day 1. So we have, let's see what we've done. So become an owner of your very own microcontroller. Yep, I've actually got quite a few of these. So that's another one in the fleet. Learned about the Raspberry Pi Pico a little bit. Hopefully I've tried to help with that. Set up your Pi Pico with Phony. Yep, we've got that working. Created our first program. Yep. Print function, indeed. And controlled a physical component with code, which is, this is kind of what the fun of this stuff is, really. It's that you can do things in the real world. Now let's get some rest and a good night's sleep for tomorrow. Continue with day 2. No spoilers. And I have literally no idea what day 2 is. I am not looking ahead here. So I'm sure other people are further ahead with this, because it's 12 projects and we're now on December the 13th. So if you're aiming this at Christmas, then you probably should have started earlier than I did, but never mind. So we will go for day 2 tomorrow and see what happens. And when will we do that tomorrow? That is a very good question. And I will try and figure that out later today and put something out on Twitter and the other places. So if you follow me on Twitter, I will try and post something later today about when we're going to do this tomorrow. I don't quite know yet, because someone's coming in to do some work on the house, and we don't want like noise in the background, or me having to like just run away and go supervise somebody. So once I've figured that out, I will figure out when we can do day 2 tomorrow. And we'll do day 2 plus a roundup of anything else interesting that has happened. So meantime, if you're bored and you want something to read, go check out my website. There's lots of projects on there. And I'll leave it there for today. So hopefully this has worked on all the channels. I'm still very new to streaming on LinkedIn and X or Twitter or whatever it wants to call itself. What we found out yesterday was LinkedIn, you don't get the comments with the names of the person through to StreamYard. So I probably need to, over on the other screen, have LinkedIn open and muted so I can actually see who it is if someone chooses to comment that way. But anyway, we'll figure it out as we go along. There's no pressure here. All right. So have a great rest of your day. And yeah, watch out on my, I'm still calling it Twitter. I'm still using the bird icon. So watch out on there, and we'll see when we get to do day 2 at some point tomorrow during the daytime UK, probably during the daylight hours, because to be frank, it makes it a lot easier to show things on a second camera when it's not dark outside and you have to flood the room with light and you get lots of reflections. But anyway. All right, take care. Bye.